In this video, we will do a second word problem example in this section on stochastic processes. So the example says, when a crab eats a floating cupcake, there is a 65% chance that he falls asleep in potions class. Without eating it, there's a 45% chance that he falls asleep. There is a 70% chance that he ate one today. Professor Snape walks into class and sees Crab is awake. What's the probability that Crab ate a floating cupcake, seeing that he's awake? Round your answer to 3 decimal places. So I want to begin this question by giving you the opportunity to try it. So pause the video for 3 to 4 minutes to try this question. 4, 3, 2, 1, pause the video and try this one for about 3 to 4 minutes. Alrighty, so let's talk about this together. And let's begin by labeling our events. So there's this matter of whether Crab eats the cupcake or does not eat the cupcake. So let's write E represents that he eats the cupcake. And let's have N represent the fact that he does not, the event that he does not eat the cupcake. And then there's also the matter of whether he falls asleep or he stays awake. So let's let S be he falls asleep. And let's let A represent the event that he stays awake. So what is this question asking us to find? I am going to write it here, and then I'm going to move it to the top of the page. But just so I can see everything, the wording of the problem, let's write it here. So I am after a probability that, there's 2 things that indicate to me that it's going to be a conditional probability. One is the previous sentence before the final sentence says that Professor Snape walks into the class and sees Crab is awake. So we are given that Crab is awake already. The other thing that indicates to me it's a conditional probability is that in the last sentence it asks, oh, what's the probability that Crab ate a floating cupcake? Seeing that he's awake. Seeing that is another way to say given that. Okay, so it is going to be a conditional probability, and we're given that he is awake, and it's asking for the probability that he eats this floating cupcake. Okay, so using our symbols, this is the probability of E given that A occurs. Okay, so I'm going to move this to the top of the page and let's continue it there. All right, so I've just copied this to the top of the page. Next, let's make a tree diagram to represent this experiment. Okay, so I will write a portion for where we begin it. Okay, so there are 2 stages to this. There's the matter of whether he eats the cupcake or not. There is the matter of whether he falls asleep or not. And then after that, I'll write down the outcome and the probability. All right, so there are 2 outcomes in this first stage. Either he eats the cupcake, E, or does not, which is N. And after that, there's 2 sub-branches from each of these, because either he falls asleep, S, or he stays awake, A. Same thing here, S for sleeps, A for awake. So the outcomes are E, S, E, A, N, S, and N, A. Let's label some probabilities. So the question said that there was a 70% chance, or 0.7 probability that he eats a cupcake today, which means there's going to be a 0.3 probability that he does not eat a cupcake, because these values have to add up to 1. The question also says that given that he eats a cupcake, there is a 0.65 probability that he falls asleep, 65% chance. It also says that if he does not eat a cupcake, there's still a 45% chance, or 0.45 probability that he falls asleep. Okay, so now we can get these other probabilities of going to A. This one's going to be 0.35, because I got to be able to add it to 0.65 to get 1. And then this one over here is going to be 0.55. So I can add it to 0.45 to be able to get 1. Okay, so now for the probabilities. Multiply 0.7 times 0.65 here. 0.7 times 0.35. 0.3 times 0.45. And then 0.3 times 0.55. Let's put some equal signs. And working out these values, this is 0.455 and then 0.245. The next one is 0.135 and then finally 0.165. So our goal, remember in this question, was to find the probability of E given that A occurs. So using the formula for conditional probability, this is probability of E intersected with A over the probability that A occurs. So writing this in words, just to get a conceptual feel for what does this mean, the numerator is the probability that E and A happen. So he eats a cupcake and is awake. And the bottom is just the probability that he is awake. Okay, so for the probability that he eats a cupcake and is awake, well, that is this outcome. That probability. Eats a cupcake and is awake, so that should be 0.245 on the numerator. On the denominator, we need the probability that he's awake. So that happens in this outcome. He's awake here. And this outcome. So that's this probability, 0.245, as well as this one, 0.165. We got to add those to get 0.245 plus 0.165. If I work this out with a calculator and round to 3 decimal places, this is 0.598. And that is our answer. So in the next video, we will do another example, but that is purely in terms of symbols and finding one of these conditional probabilities.